In today's lesson, we're looking at Chapter P, Section 1, Example 5, the set of real numbers and their subsets, and this can be found on page 8 of your textbook. So let's start with the real numbers. Real numbers are all the numbers that you can show on a number line. So I've drawn my number line here, and the first subset of real numbers are called natural numbers. Natural numbers are your counting numbers, and they begin with 1, and they continue on down the number line. And you can see that they're also positive. So these are your natural numbers, your counting numbers. They don't include your negatives and they don't include zeros. The symbol for natural numbers is an N, and the set of natural numbers can be written as 1, 2, 3, 4, ... like that. So natural numbers are your counting numbers. The next subset of numbers are called whole numbers. And in whole numbers, all you need to do is add a 0 to the natural numbers, and then you have the set of whole numbers. So natural numbers don't include the 0, whole numbers do. The symbol for whole numbers is a W with the double strand here. And to write the subset, W is equal to 0, 1, 2, 3, 4, and so on. Okay. The next subset are the integers, and integers, we're just going to add the negatives to our number line. -4, and so on. And our symbol for integers is a Z with the double strand. And our subset looks something like this. -3, -2, -1, 0, 1, 2, 3. Oh, I should have my dots at the beginning and at the end. Like that. Rational numbers are any ratio of two integers. And when I think of ratio, I think of a fraction. So basically, if you have -5/2, well, that's found on the number line. It's found between -3 and -2, so I'll just put it right here. This is my -5/2. So rational numbers can be fractions. Another example that I have is going to be 1/3, and that can be found right here. So rational numbers are fractions. They can also be decimals, as long as the decimals are repeating. So for instance, you'd want to have something like 0.66 where it's all repeating, or something that terminates. So for instance, 0.5 is equal to a half as a fraction. Therefore, 0.5 is also a rational number. So these are all examples of rational numbers. As long as they can be expressed as a ratio of two integers, then you know you have a rational number. The symbol for rational numbers is a Q. And for its set, we're going to do some symbols here. It's going to be A over B, such that, that's what this little line here means, such that A and B are members of, that's what this squiggly symbol means, or element of, integers. So A and B must be an element of the integers. And you also have to remember that B cannot equal 0 because you can't divide by 0. So when I write a subset for my rational numbers, I have to do a little bit more symbology in order to show what I mean, that rational numbers are ratios of two integers. They're a fraction where the numerator and the denominator are integers. So these rational numbers include your fractions and your decimals. Irrational numbers are your next set of subset of real numbers, and these numbers cannot be expressed as a ratio of integers. So examples of that are pi. Pi is approximately equal to 3.14, but if you were to look at it on your calculator, it actually goes on forever, and it's a non-repeating decimal. So pi, because it doesn't repeat, the decimal doesn't repeat, and because the decimal doesn't terminate, pi is considered to be an irrational number. Another example of an irrational number would be the number 2. 2 also doesn't have a repeating decimal, nor is it terminating. So pi and the square root of 2 are examples of irrational numbers. So the symbol for a rational number is an I. And reminding you that again, as a decimal, it can't be repeating or terminating. Okay, let's look at a recap. So, all the numbers on a number line can be or are considered real numbers. Real numbers can be divided into subsets of irrational numbers and rational numbers. Your irrational numbers are numbers that cannot be expressed as an integer over an integer or a ratio of integers, whereas rational numbers can be. Rational numbers can then be subdivided into integers. Integers can be subdivided into whole numbers, and whole numbers down to your natural numbers. So an example that was given in your textbook was example 5, recognizing subsets of real numbers, and they wanted us to consider the following set of numbers: -7, -3/4, 0, 0.06 repeating, square root of 5, pi, 7.3, and the square root of 81. So the first thing that they want us to do is to write down what our natural numbers are. Now, looking at our number set here, the only natural number or counting number that I can find is 81. And you might be thinking, oh, square root of 81, that seems a little bit odd to be a natural number. But when you consider that the square root of 81 is actually 9, then you think, well, 9 is a counting number, so square root of 81 is a natural number. That's the only one in the set. Moving on to whole numbers. Whole numbers include your counting numbers and 0. So I'm going to include a 0 for my whole number, and 81, as it is equal to 9, is also part of that. Integers is the next subset, and with integers we want to take the whole numbers and add our negative. So -7 is an integer, 0, and square root of 81. These are our integers in our set. Moving on to rationals. Our rational numbers include our fractions and our decimals, as long as our decimals are not are repeating, and also as long as they're terminating. So now I'm just going to add my fractions and my decimals to my integers. 0.66 is a rational because it's repeating. 7.3 because it's a terminating decimal, and again square root of 81 because it's equal to 9, which is the same as saying 9/1. -7 is a rational number because that's the same as saying -7/1, so again a ratio of two integers. Irrational numbers are numbers that are neither terminating or repeating decimal. So in this set, pi is an example of an irrational number. Also, the square root of 5, because the square root of 5 is approximately equal to, that's what these funny squiggles are, 2.236, so on and so forth, non-repeating non-terminating. And lastly, the real numbers are all the numbers in the set. Okay, moving on, checkpoint 5. One last example. Considering the following set of numbers: -9, -1.3, 0, 0.3, pi over 2, square root of 9, and the square root of 10. So first of all, let's look at our natural numbers. Natural numbers are the counting numbers, do not include 0, and in this set, square root of 9 is the only one because it's equal to 3, positive and counting. Whole numbers are your natural numbers plus 0. So 0 is in that subset, so I'll include it. And we already said that square root of 9 is a natural number. Moving on to integers. Integers are now including your negatives. So -9 is now included. 0 and 9, square root of 9. Our rational numbers are our fractions and our decimals that are either repeating or terminating. So -9, because it can be -9 over 1. -1.3, because it has a terminating decimal. That's a rational number. 0 is a rational number. 0.3 repeating, because it repeats. Square root of 9, because that's equal to 3 over 1. So these are our rational numbers. Irrational numbers are numbers that are expressed as decimals but are neither terminating nor are they repeating. So pi, symbol pi, is an irrational number because its decimal is not terminating and it doesn't have a pattern. Also, in this subset, the square root of 10 is also a decimal that doesn't repeat and is not terminating. So the irrational numbers in this set are pi and square root of 10. The real numbers in this set are all the numbers, because real numbers are all the numbers that can be found on a number line. And that concludes today's lesson. Thanks for watching.